Good evening and welcome to this interaction session. I hope you are following all the lectures. You have followed all the lectures and you're able to understand the basic nuances of surface engineering. We have had so far, I think all the lectures have been uploaded by now, and you would have also received, along with every lecture, you would have also received certain important points to be discussed or to recapitulate. By now you would have understood that surface engineering is basically for all components, all engineering components, be it for structural applications or functional applications. This is an approach whereby you change the near surface region in terms of composition and or microstructure, so that certain properties of interest can be enhanced. And we have shown you there are multiple approaches based on conventional approaches or so-called advanced approaches or advanced techniques based on directed or non-directed energy beams and so on. So, we have quite a vast coverage of the course. I hope the deliveries, the lectures have made you interested in the subject, but I haven't received many queries, only one or two so far technical, other non-technical about specific reasons as to why, I mean about contents, about rules and regulations and so on. Leaving aside those typical technical questions, just one or two. One was about, recent one was about the dimensional changes associated or not when we actually allow only phase transition related surface changes, meaning I divided the surface engineering approaches into three possible baskets, one with only change in add-on type where the dimension is changed like cladding or deposition and so on. Another where dimensions are reduced by machining or grinding, polishing and so on. And third category where we said that we don't change the dimension, but we change the microstructure or composition. And the confusion was about how can you really claim that there is no dimensional change when you are actually admitting that there is a phase transition involved. And moment you say phase transition, there is a change of crystal structure, so the specific volume should also change. Technically, it's absolutely right. This query is absolutely right, but I clarified that this no change in dimension essentially refers to a situation where the dimensions are only considered in the macroscopic scale. That means if you simply measure in terms of millimeter, you won't change, you won't see any changes. But if you go all the way up to micrometers or even lower, obviously there will be changes. So that's the typical engineering approach. We don't necessarily all the time talk about nanometers or micrometers. These are very specific microscopic changes, but by and large you're not adding or removing or machining. That's the approach. So, if you have any queries, please go ahead now. I don't know how many actually have joined so far, but if you have queries, I would be very happy to answer. So, any kind of queries if you have. This is one subject domain. I must admit that they're not. I mean, I cannot really refer you to one specific textbook because this subject domain is emerging, and actually it combines a very strongly interdisciplinary approach. I mean, you are covering techniques which are essentially covered mostly by the physicists, some are purely by the chemists, some are by the mechanical engineers, or considered to be more like mechanical engineering practices, and so on and so forth. So, one singular textbook covering the entire scope of surface engineering is not quite available. So, actually one needs to write a good textbook in this area. But what is important is that we actually develop a very comprehensive understanding in terms of the applicability, utility and service threats and various challenges encountered in real-time applications. We haven't given you many numerical problems, mainly because of the fact that this is the subject is more analytical in nature. So one needs to be able to analyze and then come up with solutions, and these solutions are not necessarily unique. So is that way difficult to claim that I mean, it's difficult to that way frame numerical questions because there could be multiple possibilities, but it's not impossible. We might come up with some numerical questions in future, but for the time being we wanted to develop the understanding of the subject purely from analytical point of view, and also keeping in eye the exact real-time applications, what happens in industry, what happens in particular examples of use or application, and so on. In fact, let me also add that if you have queries, you can always write emails using the usual forum. I think there is a provision where you can pose questions. So you are free to, actually you're encouraged to post questions whenever you have some doubts about any lecture, or even beyond the scope, I mean strictly beyond certain points if it come up to your mind which are related but not necessarily covered by the slides or the lecture delivered. Still, if you wanted a clarification, you should feel free to pose that question to us. Okay, in that case, we'll close the discussion now. If you have queries, please feel free to write emails to us. Thank you very much.